Alright, so here we are with our 4.1 properties of exponents, so exponential review. So first thing we're going to do here is just kind of identify some properties to make sure that we kind of remember what we learned in Algebra 1, supposedly. So the zero exponent property means that anything brought to the zero power is always going to be 1. So no matter what, always 1. A negative exponent property means that what you actually have is 1 over that same thing that you already had, which was x to the positive 2 in this case now. So it always means that you are going to bring something from a numerator to a denominator or back again. So then we have our rational exponents property, and the rational exponents means that if you have a ratio or a fraction as your exponents, what you're going to end up having is actually that this is x to the 4th, but then it's the third root of x to the 4th. You can also end up doing the opposite of that as well, which is going to mean that you would first do the third root of x, and then to that you could bring it to the 4th power. So there's two ways of thinking about that one. The next one is your multiplication property, which means that once you have the same base but different powers, you can go ahead and have that same base but now have those properties added, in fact. Most people will want to multiply them, but of course the multiplication property in this case actually means that you add the exponents. Alright, your division property is not going to divide the exponents, it's going to subtract the exponents. So what we're going to see instead is x to the numerator minus the denominator, so 9 minus 2, or 7. So I guess I could solve this one and give you x to the 9 and then x to the 7. Alright, and then the last one, the exponent property, so you have an exponent of an exponent, means that I would be writing x to the 3rd times itself 7 times, right? And so that means that I would be writing 3 7 times, which means 3 times 3 times 7. So in this case, 3 times 7 is going to equal x to the 21. So those are some of the basic properties that you are going to apply. And of course, if you look forward to some of the next examples, you can see that it then uses a bunch of these all at once. So we'll go through those. So all the rest of these are examples that we'll be going through on our notes. So just to kind of see what's happening. So this first one here wants you to take 27 and bring it to the 1/3. Now, if you have a fun calculator, you can of course just put this in, but the idea is that you know where it comes from. So in this case, I actually have a 27 that is being brought to the 1st power, and then it is the third root of that. And so what does a third root mean? It means something times itself again 3 times is going to equal 27. And so what is that number that will multiply by itself 3 times? That's going to be 3. Alright, the next one is going to have 25, and it's being brought to the 3rd and then square root. So remember that there are two ways of doing this. You can either write 25 and then have it to the 3rd power, and then take the square root of that. Or you can actually do the other way, which is the more helpful way in this case. So in this case, I'm going to actually be doing the square root of 25 first, because hopefully we know that's going to be 5. And then from there, I'll bring it to the 3rd power. So that means that we have 5, and 5 is being brought to the 3rd power, and so 5 times 5 times 5 is 125. Again, something you could type into your calculator, 25 caret 3 division sign 2, but I don't want you to do that because I want you to actually know where it came from. Alright, the next one here is a very large number brought to the 0 power, and so as we said above, it's 1. So it doesn't really matter what that thing is that's being brought to the 0. If it has a 0 power, it is 1. And then this last one here is going to be instead rewritten as 1 over and now 2 to the positive 3 instead of negative 3. And so we will continue this one and simplify. So that's actually 1 over 2 to the third, which is 8. And so 1 over 8 is actually 2 to the negative 3. If you do this with a calculator, you are going to get 0.125 because that's 1/8, but we don't want that. We want the actual fraction. Alright, the next one uses our multiplication property, so this is going to be x to the 5 plus 3, and so we have x to the 8. And then the next one is our division property, so we're going to have x to the 7 minus 3, or x to the 4. Alright, now we start to get into the super fun parts. So what happens here is we're going to break this into each of its pieces. So, first thing here is going to be applying this squared of the denominator. So the squared of the denominator says that we have negative 6h to the 0 times negative 6h to the 0. Well, if you think of it in a different way, negative 6 times negative 6 times h to the 0 times h to the 0, you actually have positive 36 times 1 times 1, which of course is just 36. So our denominator is 36, but then our numerator is all of these other pieces. So our numerator is negative 3h to the 6 times g to the negative 2 times an h and times a k to the negative 2. And all of that is going to be over the 36 we just found. So if we simplify that a little bit, I'm trying to find any of the h's that might go together. So notice there's an h to the 6th and an h to the 1 that we could put together, which means that we'd really have negative 3h to the 7, because they are multiplied, everything on top here, but still have g to the negative 2 and k to the negative 2. And so how do we go ahead and simplify the fact that there are negative 2's up here? That means that we are going to bring these two things down to the denominator, because a negative exponent means bring it to the denominator. Which means that in the numerator we'll still have negative 3h to the 7, but in the denominator we'll have 36, and then we've brought down the g squared and the k squared, which are now positive because they're in the denominator. We've moved them. The only other thing to simplify is our number. Looks like we have 3 over 36, and you should always simplify if you can. So instead, how many 3's go into 36? Well, there's going to be technically a negative 1 on top, and then 12, because 3's are 12 times into 36, and then our g squared and our k squared. So how much simpler does that look? Not much, but the idea is that you combine anything that is an alike base, so our h's were combined. Anything that has a power, you're going to want to apply that power to everything in there and kind of simplify if you can, and then of course simplify numbers if you can as well. This last one, the numerator here, ends up actually kind of working like the denominator did in this one. And so in that case, what we're doing is applying this 3 as the base to each of these y's and x's. So that 3 is now going to be in the denominator, so we have x to the 6, but then divided by 3. And then we'll also have y to the 6, but divided by 3. Oops, wrote that backwards. So in the numerator, if we simplify, that means that we'll have x squared and y squared over yx squared. And it's okay if they are backwards. You can rewrite in multiplication anything before another thing. So I can write x squared, y squared, and then x squared y. I can flip those in the denominator. And so because of that, if you think of this as two separate fractions, which you can, x squared over x squared is going to become 1, and y squared over y to the first becomes y to the 2 minus 1, which is just going to be y. So all of that ridiculousness at the beginning simplifies to just be y. So A few things from this one. You know that you can apply a square root to anything that's underneath that root, and anything inside. We also realize that we can rearrange things. So if you want to kind of think of the x's on top of the x's and the y's on top of the y's in order to think of their division happening, you can do that as well. So kind of a lot of application that you will be doing on the next side of this worksheet as your assignment.